In 2012, Voyager 1 made history by becoming the first spacecraft to enter interstellar space. Since then, it has been exploring the vast expanse of deep space, sending back invaluable data and images of the universe beyond our solar system. However, in 2021, something unusual happened. Voyager 1 made contact with an unknown force deep in space, leaving scientists puzzled and intrigued. What could this mysterious force be? And what implications could it have for our understanding of the cosmos? Join us as we delve into the fascinating journey of how Voyager 1 made contact with an unknown force in deep space. With the invention of rockets and satellites which allow us to start space exploration, humanity's desire to solve the mysteries of the cosmos has only become more intense. The Voyager mission has taken us to previously unseen distances, taking us outside of our solar system and revealing the vastness of the cosmos. This is more than we can understand, but there is no question that our world is amazing. Compared to the size of the cosmos, it is little. How may we continue to explore this uncharted frontier? For over 45 years, the Voyager missions have been essential to space research, providing us with priceless early insights into the fundamental makeup of our solar system. Nevertheless, these missions were never intended to endure for such an extended period, as the Voyagers persist in transmitting data for analysis. A terrifying warning that might completely change all we know has been issued. NASA officials had originally planned for the Voyager's mission to last just 5 years. Yet Michael Minorick's accidental discovery that a spacecraft may use a planet's momentum to drive itself further into the solar system gave rise to the idea of sending out probes. Both Voyager 1 and 2, which were launched within weeks of one another, have far survived their initial anticipated lifespan and are currently gathering essential scientific data from the furthest reaches of space. Following successful explorations of these planets, Jupiter and Saturn were given to Voyager 1 and 2, respectively. By conducting close-up investigations of Uranus in 1986 and Neptune in 1989, Voyager 2 made history and opened the door for the Voyager Grand Tour's reconnaissance of the 4 planets. After then, the 2 spacecraft started a new mission to explore the furthest reaches of space. According to a declaration made in 2013, the Voyager 1 had reached the line dividing our solar system from interstellar space. The area between the stars when the sun's magnetic field and particle stream come to an end is referred to be interstellar. As per NASA, Voyager 2 also crossed over into interstellar space in 2018, when it was positioned 17.7 billion kilometers away from the Sun. The only probe that has traveled into interstellar space as of right now is the Voyager mission. They studied the interactions between the solar wind, the perpetual motion of electrically charged particles from the Sun, and the interstellar medium throughout their whole journey. Also, they provided important knowledge on the heliosphere, a protective shell that surrounds our solar system. Interstellar circumstances and the solar wind have made an impact on how the heliosphere is configured. This line of demarcation between the solar system and the interstellar space is known as heliopause. According to NASA, the Voyager probes have given us new insights into interstellar space. One of their discoveries is that cosmic rays are approximately 3 times as intense outside the heliopause than within. To get a more complete understanding of the Sun and the heliosphere's interactions with interstellar space, researchers have combined findings from Voyager with data from latter missions. In 2022, it was discovered that Voyager 1 had recorded a buzzing sound connected to waves found in the tenuous interstellar space. The chief of NASA's Heliophysics Division in Washington, D.C., Nicola Fox, emphasized the important insights into the Sun and its impact on the solar system that the Voyager missions have provided. According to Fox, no other spacecraft has been able to evaluate our understanding of the Sun and its effects in the same ways as the Voyagers have during the past 45 years. According to NASA, the thermoelectric power system that powers the Voyager probes uses plutonium to produce heat and electricity, which gradually decreases as the plutonium decays. The scientists turned down all non-essential equipment, including heaters that shield still operational instruments from the space environment's freezing temperatures, to counteract the declining power. The space agency maintains that despite having their heaters switched off since 2019, all 5 instruments are still operational. How Voyager can continue to operate in temperatures that are much lower than its design parameters continues to baffle NASA experts. At the furthest reaches of our solar system, researchers have found something remarkable. Recent measurements have shown that the heliopause, which marks the transition between the heliosphere and interstellar space, is experiencing unusual activity. It seems that the heliopause is ripping and creating angles that never have been seen before. Heliopause is not a static border, even though scientists have known for some time that it may change form. Studying data gathered by NASA's Interstellar Boundary Explorer (IBEX) satellite and the Voyager 1 and the Voyager 2 spacecraft led to the finding. These spacecrafts have given important insights into how solar wind's interactions with interstellar medium create emissions of energetic neutron atoms that ionize light. As noted by Eric Bernstein, a space physicist at Princeton University, in an email to Vice, while the Voyager probes have gathered direct in situ measurement of the position of these limits as a single point in space and time, IBEX helps to supplement this data. When taken as a whole, these missions have significantly improved our knowledge of heliopause and how it responds to shifting interstellar circumstances. Models anticipating the future changes of the heliopause, the continually moving border generated by the interaction between solar winds and the interstellar medium, have been developed by scientists using data from the Voyager spacecraft and NASA's Interstellar Boundary Explorer (IBEX) satellite. Recent research on heliopauses, however, discovered information that contradicts earlier conclusions. IBEX discovered in 2014 that the brightness of energetic neutral atoms was getting brighter every night, indicating asymmetry in the heliopause over a few months. Subsequent investigations showed that these disparities did not match the voice-reported current models. Moreover, after analyzing the data from Voyager 1 and Voyager 2 over a very brief period, researchers noticed a noticeable movement of the heliopause. This explains the large gap in time between the 2012 and 2018 departures of the 2 spacecraft from the heliosphere of the solar system. The researchers described these discrepancies as intriguing and even problematic because the change in the heliopause position defies accepted theories. According to a report released on October the 10th, scientists intended to utilize NASA's Future Interstellar Mapping and Acceleration probe to further their study of the heliopause. This cutting-edge satellite, slated for flight in 2025, is intended to detect NASA. Yet it is still unclear what caused the odd activity that was seen at the furthest reaches of the solar system. Voyager 1's Altitude, Articulation and Control System Act started sending out of the ordinary data in May. This discovery was disclosed in the journal Nature Astronomy, rather than the anticipated routine reporting on the state of the spacecraft. There has been a tremendous movement that defied accepted explanations along with heliopause. These differences were described by the researchers as fascinating and maybe contentious. The spacecraft looked to have encountered a situation like electrical asphyxia, which may make it difficult to communicate clearly, according to a statement from NASA at the time. The produced data may have been random or may not yet have represented any plausible condition at all. The fact that Voyager 1 looked to be in perfect shape from our vantage point, despite the odd status reports from the spacecraft, confused the engineers even more. Moreover, both spacecraft scientific equipment is still gathering data and sending it back to Earth without any problems. Throughout the past 10 years, Voyager 1 has been moving into interstellar space outside the magnetic field of the Sun. As a result, the spacecraft is exposed to cosmic rays and other types of interstellar radiation, which are generally shielded from Earth by the planet's magnetic field. In addition, we have entered interstellar space, a very radioactive region that no spacecraft has ever traveled through. The spaceship has made some very remarkable journeys so far. That's it for today's video. So what do you think this unknown force could be? Let us know in the comments below, and don't forget to subscribe for more fascinating space-related content. Thank you for watching. Tent.